This week we're going to be learning about vectors. This is an example here of what's called a scalable vector image, or SVG. It's a different type of image compared to other images you might be familiar with, like bitmaps or JPEGs. The cool thing about this type of image, because it uses vectors, you can zoom in an infinite amount and you never get the pixelation that you notice with JPEGs or bitmaps. So if you're interested in that, Google an SVG image and you'll learn more about this and how it's related to vectors. But let's see what we're going to learn about vectors this week. We're going to use vectors in our class. So first I want to distinguish between a scalar quantity and a vector quantity. So a scalar quantity are probably most things that you're used to. These are quantities that are fully described by just a number and their units. Okay, so when I say just a number, something where you just tell me what the number is and that's all you need to know. For example, how much money do you have in your bank account? That's just a number and units. The units would be dollars. Okay, maybe your bank account has $30 in it. So that is a scalar quantity because I know everything about your bank account by knowing the number, $30. Okay. A lot of quantities that we'll talk about in physics that are scalars would be things like time. Time is a scalar because you can completely describe, how long something takes just by telling me the number of seconds. That is distinguished from a vector quantity. And a vector quantity, in order to fully describe it, you need the number and you also need a direction. And when I say direction, for now, you can just think that means north, south, east, or west. Okay, so let's go back to a scalar, like the amount of money in your bank account. I would never say something like you have $30 southwest in your bank account. That doesn't make sense because the quantity of how much money you have in your bank account is a scalar. There's no direction associated with that. But let's consider something that's a vector quantity. That could be something like position. Okay, so let's say your friend calls you and you say, hey, what's up? Where are you? And your friend says, come pick me up. I'm 6 blocks away from the 7-Eleven. Well, 6 blocks is the number part. Okay, that's where you're kind of giving me an idea of where you are. You're 6 blocks away from the 7-Eleven, but really I need to know in what direction. Are you 6 blocks north of the 7-Eleven? Are you 6 blocks south of the 7-Eleven? Are you 6 blocks east of the 7-Eleven? Are you 6 blocks west of the 7-Eleven? That's very important. So something like position is a vector quantity. Because to really know exactly what you mean by that value of position, I need to know the number, how big, how many miles are you away from something, how many blocks are you away from something, how many meters are you away from something, and what direction are you away from that thing. Okay. If we think of a scalar quantity, that could be something like speed. That's just how fast are you going. A vector quantity would be velocity, because velocity includes the number part, are you going 7 meters per second? That's the number. And the direction. Are you going in the positive x direction, which we're going to start to call east? Are you going in the negative x direction, which we're going to start to call west? Are you going in the positive y direction, which we'll call north? So to fully describe a velocity, you need both the number and the direction. Okay, so we're going to play a lot this week with different vector quantities, and then as we go forward this semester, a lot of the different values we calculate are going to either be scalar quantities or vector quantities. Let me mention that the number part of a vector has a special name, and that's called the magnitude. Okay, so if you say I'm 6 blocks west of the 7-Eleven, the magnitude is 6 blocks. The direction is, of course, west. So let's look at 2 different vectors that we're going to play with a lot this semester. The first one is velocity. Okay, we already know that we use a v to represent velocity. We've been doing that in the past. What's new here is the arrow on top. The arrow indicates that the quantity we're talking about here, velocity, is a vector. So whenever we have the arrow on top, that means the thing we're talking about is a vector. And the vector is described by 2 pieces of information. The magnitude, which is the number, and we would put that, the notation we're going to use is we're going to describe our vector we're going to use parentheses. The first thing that goes in the parentheses is the magnitude. That's just how big is it. It's just the number and the units if we need units. So this might be something like 5 meters per second. I'm using v because another thing that we're going to find is that when we're talking about the magnitude of our vector, we can use the same variable that we've used here. We just don't put the arrow on top. When it has the arrow, it means we're talking about the full vector, which is the magnitude and the direction. When we don't have the arrow on top, we're talking about just the magnitude, which is just the number part of it. Okay? And then the second thing that comes in our parentheses is the direction. So here I'm just writing it as theta, which is just a general direction. Okay, so an example of a velocity vector might be 5 meters per second, comma, 20 degrees. That would be my direction. Okay, so this is a notation that looks confusing in the beginning, but we're going to use this a lot to describe a vector. Again, the first part is the magnitude, the second part is the direction. Now, when we're drawing pictures, we're going to represent our vectors as having a starting point and having an end point. The direction of the arrow tells us the direction, in this case, of the velocity. So this is similar to what the kinds of arrows we drew when we made motion diagrams. It's pretty much the same thing now. Our magnitude is going to be represented by the length of this arrow. Okay. And the angle theta is always, 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 always measured with respect to the horizontal. So in this case, here's my angle, or here's my vector. I would draw like a dotted line here along the horizontal, and the angle theta is the angle between my vector and the horizontal. So that's what theta represents. Another new piece of notation you're going to have to get used to is this absolute value. So when we take the absolute value of a vector, what that really means is we're just calculating the magnitude. Okay, so here is one way to say just get the magnitude. You put your vector in the absolute value sign. Another way to say I'm just talking about the magnitude, again, is to just write the variable without an arrow on top. And the velocity vector has a very special name for its magnitude. The magnitude of a velocity vector is speed. Speed is just how fast are you going. It ignores direction. So the magnitude of our velocity is speed. Okay, that's what this whole thing is saying here. Let's look at another vector quantity. Another vector quantity we're going to do is position. So far, when we talk about position, we have only described x position or y position. But now our position will have x and y components to it. So we're going to use the variable r for position. Okay, so position is a vector because we need to know a magnitude and a direction. For example, when we talked back up here, where are you? That's like saying, what is your position? And that is a vector. You need to know, for example, if you're saying where you are with respect to the 7-Eleven, you need to know how far away are you from the 7-Eleven. That's what would go here. This could be 6 blocks, for example. And what direction are you from the 7-Eleven? That is a way to describe your position as a vector. Again, we always take our direction with respect to a horizontal. So we draw like a dotted line here, and that would be the angle that we would measure. And the length of this vector would be the magnitude of my position vector. Here I'm taking the absolute value of my position vector. That is equal to my magnitude. Here's I'm writing the magnitude because I don't have an arrow on top. And the magnitude of your position vector also has a special name. It's just distance. Just think just how far. That's the magnitude part. How far away are you? If you really want to know where somebody is, though, you need to know both how far away they are, what's that distance, what's that magnitude, and what direction. Okay, so this is just the beginning of playing around with these vectors. We're going to spend so much time with these. We're just introducing them, and this week we're going to learn more about how vectors behave.